If you've been following along, several of my past videos featured 3D printers that extrude plastic filament, but that's not the only game in town. Resin-based printers are becoming affordable as well, and while their build volumes don't generally compete with those of their filament counterparts, they claim a different strong suit, namely print quality. Do a YouTube search for Resin or SLA printing videos and you'll see pages upon pages of content featuring tiny, incredibly detailed prints ranging from D&D miniatures to jewelry to dental appliances. All very interesting things, I'm sure, but not really. So as you can see, I have a resin printer of my own, courtesy of Longer 3D, and of course I wanted to explore the possibility of using it to create some audio-related contraption, since that's kind of my thing. So settle in for a vibrant adventure and a fun project complete with a demo. So, this is the Orange 30 from Longer 3D. Not much in the way of assembly, so let's talk about how it works. Right away, there's only one moving part, and that's the build plate riding up and down the Z-axis, offering 170mm of travel. The individual layers are cured into existence with a powerful UV light projected from beneath and an LCD panel masking parts of it to form the shape of each layer. So the precision on the X and the Y axis depends on the resolution of the LCD panel, and this one fits 2560 by 1440 pixels into the space of 120 by 68mm, resulting in a pixel density nearly twice that of a modern Retina display. As such, the build volume comes out to 120 by 68 by 170mm, which I have yet to see anyone take full advantage of, so let's do just that. And there's a new arrival at Parts Express, namely this adorable 1 1/8 inch full-range driver from Tectonic, which, after some modeling, looks to be a good candidate for the available space. In fact, a pair of these will go into an equally adorable extended-range transmission line, which I've modeled specifically for this occasion. There may be some debate as to whether this is, in fact, a transmission line or a base reflex, since the initial fold is wider than the remainder of the waveguide, introducing an element of capacitive reactance, thus raising the acoustic order to fourth. In either case, it's designed to play well into the upper bass, aiming for a warm, natural tone at a ridiculously small stature. And as I've noticed a number of comments from viewers seemingly puzzled when I refer to bass, mid-bass and such like, let's take a moment to define our terms.
Right now?
Yes, right now. So the human hearing spans a bandwidth of 20Hz to 20 kHz, the very bottom of which is referred to as the sub-bass region, covering 20 to 60 Hz. This is where the fundamental frequencies of the lowest pitch instruments tend to reside. Just above that, between 60 and 250 Hz, we have the bass region, further classified as the mid-bass and the upper bass. The fundamental frequencies of most rhythm instruments can be found along this part of the spectrum. Further up, between 250 Hz and 2 kHz, we have the lower and the upper mid-range, covering the low-order harmonics of the mid-tone instruments. This is also where the bass instruments gain a lot of their presence. The upper 3 1/4 octaves are referred to as the treble. This includes the lower treble between 2 and 3.5 kHz, which defines the attack of the percussive and the rhythm instruments, mid-treble between 3.5 and 6 kHz, which gives the mid-tone instruments their presence and carries most of the vocal sibilants, and finally the upper treble, also known as the brilliant, which contains the upper harmonics for the percussive and the mid-tone instruments. Alright, grab a screenshot and back on topic. So the printer comes with its own slicer, which gives you all the basic functionality for scaling, rotating, and generating supports, or adding them manually. It's also compatible with third-party slicers like Chi2Box, but for the purpose of this video we'll stick with the native software. And for my first attempt I'll add the supports manually, since the ones that generate automatically seem a tad overabundant. I'll also have the print begin right at the build plate to improve adhesion and to ensure that we don't exceed the build volume on the Z-axis. Next, let's go ahead and level the build plate, and this is very easy to do. We just remove the VAT, loosen the 4 adjustment bolts, leaving the build plate to move freely, lay a sheet of paper down over the LCD panel, home the Z-axis, tighten the bolts with the build plate resting flat against the paper, and replace the VAT. Now then, it's never a good idea to be in the same room with a resin printer as it's running, and while most photopolymers are reasonably safe, while in liquid form they can give off an unpleasant odor, so I've set up a tiny work area right there in the corner of my garage for the warmer parts of the year. It's literally just a sofa table, one of those metal swing arm lamps, and an orange LED bulb. I've also picked up a reasonably powerful UV light, a turntable, and some glass containers, which we'll come back to later. In the meantime, let's get into the resin, and the suggested temperature for this stuff is around 25 to 30 degrees Celsius. Compare that to the 12 degrees currently in my garage, and I'm inclined to print right here. As you'd imagine, there is a wide assortment of colors to pick from and no shortage of vendors to shop with. What's more, resin can also be translucent, so if you fancy a see-through print, well, here's a liter of clear from Anycubic. I don't actually know how much I'll need, but it's better to refill several times than to overfill even once. So while that's going, let's talk about all the orange. Starting with the fact that 3D printing resin cures when exposed to a particular wavelength of light, namely 405 nanometers, which marks the very bottom edge of the ultraviolet spectrum and has about as much energy as visible light can. What's more, just about any source of white light will carry some ultraviolet. This is why photopolymers solidify under sunlight. Obviously, we don't want that happening to the resin in the vat, so we shield it with a filter that can only pass much longer wavelengths with energy levels low enough not to affect the chemical bonds, right around 620 nanometers, aka orange. And when I have the cover off to add more resin, or just to be nosy, I don't want the light source interfering with the chemical process, hence orange.
It's so simple.
I could have gone with red, which at 680 nanometers marks the lower edge of the visible spectrum. However, that wavelength doesn't really trigger pupil contraction, so it takes a while for the eyes to adjust. Anyhow, it looks like we're done with the first half of the print, so let's pull it out, pry it off, and give it a bath. By the way, best removal tool ever. It actually comes as part of a kit, and I'll leave a link to it down below. Anyhow, once the print comes out of the vat, there is still a bunch of uncured resin all over it, and this is where the glass containers come into play. I fill them with isopropyl alcohol, submerge the print, agitate it for a little while, then blast it with this 20-watt UV light to reinforce the polymer bonds. Really, it's like a chemistry set for grown-ups. And once all the supports have been removed, we can examine the final product. As you can see, the level of detail around the speaker insets is impressive and the clearance is dead on, though I can definitely see how the features parallel to the build plate could have used some additional support. Looking even closer, you can see how the resin clumped along the walls and the two rightmost grooves didn't quite resolve, the outer one especially. There's a similar issue with the groove along the back of the enclosure. What's more, given the size of these features relative to the pixel density of the LCD panel, this is somewhat unexpected and, for all intents and purposes, unusable. So let's make some adjustments and try again. This time I'm letting the slicer generate all the supports it deems appropriate. And just to minimize any likelihood of the UV light shining through the translucent walls, curing what it shouldn't, I'll switch to black resin. So let's fast forward through the 12-hour print job, and once the half shell has made it into the bath, Sophie discovered that she really enjoys removing the supports, so here's Sophie removing the supports. With the black resin, it's also a lot easier to see just how much of the uncured material is left behind. It's also a reason to wash it off in 2 stages.
Once for the bulk and again for the remainder.
Finally, after a few minutes on the turntable, we can examine the results. And things are looking a little better, though the groove along the back of the enclosure is still missing its outer lip. The features along the edge of the compression chamber seem well defined, though the ones along the very outer edge remain deformed, which baffles me as it's the exact same geometry. For the moment, I'll assume that the further we get from the build plate, the less accurate the layer placement becomes, making this an inevitable, hence a consistently reproducible artifact. This may also explain why no one ever prints models anywhere near the full size of the build volume. Nevertheless, while I have no shortage of patience, I do have a finite supply of the black resin, so if this is as good as it gets, we may as well proceed with the other half. Besides, there is one more thing that I can try, and that's to increase the exposure time, giving each layer more of a chance to solidify, which should, in theory, solve the warping issue. But, as a middle finger to my intuition, the opposite happened. And apart from the warped features, the print also came out with what I can only describe as a layer shift. So I reverted to the settings used for the previous half shell with the default exposure time, and things just kept getting weirder. Especially as I haven't been able to establish a solid correlation between what I did in the slicer and the resulting issues with the prints. This is where I decided to gain some perspective. Ultimately, either I'm doing something wrong or the printer is. And the only way to sort that out is to have the machine complete a factory pre-sliced reference model included on a USB drive using the complementary bottle of longer 3D resin. So with everything cleaned up, re-leveled, and buttoned down tight, I set off to print the 3 wise skulls that see, hear, and speak no evil. 9 hours later, I am both saddened and relieved. Obviously, this isn't supposed to happen, but it also goes a long way to explain my consistent lack of success getting anything to print as it should. So whether the machine has a faulty display or some related malfunction, the odds of me slicing my model incorrectly have just become insignificant. I've also communicated this to the folks over at Longer 3D, and the upshot is another video once the replacement machine arrives, so we'll call this Part 1. In the meantime, I did promise a demo, and as it happens, my plan was to compare the acoustic properties of resin and thermoplastics. So if you paid close attention to the B-roll just before the title sequence, that's actually a second transmission line being printed out of PLA. Not only that, but perhaps as a bit of redemption for the brand, that's another longer 3D machine equipped with a spring steel plate. And it's been cranking out prints like this since the original video featuring the mini bookshelf speaker. So now let's get the half shells prepped, and to minimize the load on whatever device I end up using to power the speakers, I'll wire them in series. Handing it off to Sophie now to get some JB weld into the grooves, and 24 hours later the enclosure is ready for the drivers. No need for blue tack here, as the backs of the mounting rings are lined with this foam-like insulation, so in they go, and now we're ready to do some testing. Just one minor update. Since I composed the narrative as the story unfolds, the predicted response that I showed earlier was for the enclosure made with resin. This one is modeled with the structural properties of PLA. So now let's get to some real world data. Here's the Zoom UAC2 as my consistently reliable source, feeding through the Mini DSP 4x10 in bypass mode, continuing onto the Mackie HM400 where the signal is mixed down to mono, then carried out to a single channel on the Dayton DTA100, played through the speakers and captured with the EMM6 using one of the XLR inputs on the Zoom interface. It's the circle of whatever, let's do the thing. And we're pretty much on target, though I'm still working on a way to anticipate these upper band irregularities, which I suspect may be related to how the drivers reinforce each other as the projection patterns become fragmented around the beaming frequency. Chime in if you have a different theory, but in the meantime let's just listen to some music, and here I wanted to try something different. Ordinarily, this is where I'd capture the sound using the Mini DSP ears and my field recorder, inadvertently dragging things out with playback in both formats. This time I've set up a matched pair of cardioid mics in an ORTF arrangement, which should capture both the sound source and the ambience of the listening space, translating well to both speakers and headphones. Have a listen. Alright, this is just to verify you have your headphones on the right way. This is your left, this is your right. Now for the music. I do like the sound of these drivers, and the enclosure does an excellent job reinforcing the mid-bass, giving the music a snappy, dry punch, which becomes more apparent as I go to cover and uncover the vent. There's a huge difference. Not sure if you can tell or not. Huge difference. This is entirely suitable for casual listening, though a subwoofer would definitely round things out. Now then, I'm obviously not going to have anything conclusive to say about the Orange 30, and the reason that any reputable company offers a replacement plan is because a lot can happen between the factory and the recipient. So we'll come back to that in part 2, as I do have a few interesting project ideas for which a resin printer would be ideal. In the meantime, I'll wrap things up with a couple of announcements. First, I now have an Amazon storefront which I'm in the process of populating with the various products you've seen throughout my videos, most of which I bought out of pocket based on my own research. So if you have questions about a particular tool, gadget, or an accessory, check out the links below. Second, I have finally gotten my Patreon set up, and it'll feature a quarterly Q&A video, so if you'd like to join, I'm already accepting questions for the very first episode. No topic is off the table, so if you'd like to ask about, I don't know, the airspeed velocity of an unladen swallow...
What do you mean? African or European swallow?
By all means. I've also updated my Thingiverse account with a model from today's video, and as you've just seen, you don't actually need a resin machine to print it, just be sure to slice it with supports. Anyway, I hope you enjoyed the video, don't forget to rate it accordingly, subscribe if you haven't already, and I'll see you in the next one. Cheers!